Hello everyone. In this video, we are going to cover the topic operations on real number. Okay, so in this video, we will try to add two real numbers or subtract, and we will do some properties as well. So first of all, it's there real number is equal to rational number plus irrational number. Okay, and we can do these four basic operations on them. Suppose I have 2 as the rational number and under root 2 is irrational. So 2 plus under root 2 is irrational, like sum of rational and irrational is irrational, but it's the real number. Okay, but the thing written there is not which I have explained there. The basic idea is that if we collect all rational and irrationals, then we will get the set of real numbers. Okay, so real numbers are the set of rational and irrational. Now it's their addition of real numbers. So when we add two real numbers, the result is always a real. Okay, which means suppose we have any two real numbers, let us say x comma y, such that x comma y are real numbers. Then x plus y is also real number. For example, we have two real numbers, suppose 2 and another one is under root 3. One is rational and another one is irrational, but they are real, as real is the collection of both. So if I add 2 plus under root 3, then it's a real number also. Okay. Now subtraction of real numbers. It's already the same. Difference of two real numbers is also real. For example, if I have 5 and 2, then 5 minus 2 is equal to 3. 3 is rational and rational is real. So I can write like that. Suppose I have 3 under root 2 and under root 2. Now 3 under root 2 minus under root 2 is equal to 2 under root 2. It's irrational, so it will be real. So subtraction and addition of any real numbers will be real number. Now the next one is multiplication. Yes, for that one property is same. The product of two real numbers is always real. For example, I have 3 and under root 2. If we multiply, I will get 3 under root 2. It's irrational, but it's real because real number contains all the irrational and rationals. Suppose I have under root 5 multiplied by under root 5. So it will be is equal to 5. So it's rational and it's real. Now division of real number. Division is possible for all real numbers except division by 0. Suppose I have any two real numbers like x and y are real. Then x divided by y is possible only when y should not is equal to 0. Okay, we can do that thing if we have the denominator should not equal to 0. Okay, so that's the thing. And for example, suppose I have any two real number 5 and 2, then it will be is equal to 5 by 2. It's also real. Now there are some identities related to square roots, which means suppose I have square root of any number a. Okay, so what are the properties associated with them? First of all, there is the product rule, which states that suppose I have two numbers a and b, they should be non-negative. Okay, we cannot define like under root minus 2. It's we don't know what it is. Okay, so we cannot do like that. We only do under root 2, under root 3 like positive integers inside the under root. So if we have two numbers a and b which are non-negative real numbers, so under root a and under root b. So if we multiply them like under root a multiply under root b, then it will be is equal to under root ab. Okay, which means For example, I have to multiply under root 3 multiply under root 11. So it will be like under root 3 multiply 11 and it will be under root 33. Now the question tool. For question tool, suppose I have two non-negative real numbers such that I have to find under root a divided by b. There is a condition b should not equal to 0. Then if I have this, I can write under root a by b is equal to under root a by under root b. Okay, for example, if I have like under root 15 divided by under root 5, I can write it as under root 15 by 5 and 5 threes are 15. So it will be equal to under root 3. So this is used for simplification also. Now square of square root, which means suppose a is any real number positive we have defined, then square root a. There is written square of square root. So square of square root will be the number a itself. Which means suppose I have a square of under root 3, then it will be is equal to 3. Now you can answer if I have square of square root 5, what will be the answer? So using that property, the answer is 5 itself. Now square root of square. Suppose we have numbers which we already discussed, a and b non-negative real numbers. And I have a square, then square root of square should be mod a. Okay. Which means if I write square root of 9 square, the answer is 9. If I ask you what is the square root of 3 square, can you answer me? Answer is 3. Now the fifth one is square root of a fraction. Okay, so in this property, what we can do, suppose I have a fraction like a and b. Okay, suppose it's the square root under root a by b, it will be is equal to under root a by under root b. Okay, it's same we have discussed also there, question 2 like that. Okay, now the last one is the conjugate identity. Suppose I have under root a minus under root b, and if we multiply under root a plus under root b, then there is a no need to solve this one. We can directly write the answer is a minus b. For example, if I have under root 3 minus under root 2 and under root 3 plus under root 2, then we can directly write its answer is 3 minus 2 is equal to 1. Okay, that's the conjugate identity. Now there is a one more topic in this one, which is known as rationalization. So what's the rationalization? Rationalization means removing the square root or irrational number from the denominator of the fraction. Which means if I have a fraction like that 1 upon under root 2, then how we can remove the under root 2 from the fraction? So that's the way of rationalization. So to do that, we can multiply numerator and denominator by a suitable number, often the conjugate, to make the denominator rational. Okay, so for that we have to multiply like a by b is there under root, then we will multiply some fixed number in denominator and numerator such that the answer will be rational in the denominator. So there are the cases. The case one, denominator in the single square root, which means suppose I have a upon under root b, then what we can do, simply multiply under root b in numerator and denominator. It will be a under root b and under root b square, and using the above property we can write it as a under root b by b. Now it's in the rationalization form, as in the denominator there is a no fraction, or we can say no like square root. Okay, now if I have 2 under root 3, try to solve with myself. Now we can write multiply under root 3 in denominator and numerator. As we have to make it the perfect square, it will be 2 under root 3 by 3. Okay. Now the case 2 when denominator is of the form square root a plus square root b, which means in denominator we have square root a plus square root b. Okay, so what we can do, like we have suppose, okay, now consider first this one. If we have square root a plus square root b, then which number we can multiply to it so that the answer will be rational. Okay, now look there, conjugate identity. Like if a under root a plus under root b, I will multiply under root a minus under root b, then answer will be a minus b, which is real and rational also. So if in such cases we can multiply under root a plus under root b multiply under root a minus under root b. So answer will be a minus b. Now for example, I have 2 divided by under root 5 minus under root 3. So what we can do? First of all, we will write the thing as it is. Then we will multiply under root 5. Okay, the denominator is of the form plus. So we will multiply under root 5 minus under root 3 and same thing in the numerator. So it will be is equal to 2 inside the bracket under root 5 minus under root 3 and it will be 5 minus 3 which is equal to 2 by 2 and in the bracket under root 5 minus under root 3, 2 will cancel out. It will be under root 5 minus under root 3. Okay, that's in the form of the rationalization. Now the case 3 when denominator is of the form square root a minus square root b. Okay, that's also same with the previous one. You have to just multiply the conjugate. Okay, suppose you have square root a minus square root b. Then what you can do? You will multiply square root a minus square root b and square root a plus square root b. Okay, you can take the previous example and solve for this one. Now the last case when higher power in denominators are given. For example, if it's given that 1 upon a is to power 1 by 3. Okay, so what in that case, what you can do, you will multiply a cube and a cube there. So answer will be a cube and a is to power 1 by 3 and this, so you will get the answer. Okay, so let me take an example. Wait, this should be more clear. Suppose I have like 1 divided by 2 to power 1 by 3. 2 to power 1 by 3 is equal to cube root of 2. So what we can do, we will write 1 by 2 to power 1 by 3 as it is. Now we have to make power of denominator 1. So what we can do, we will multiply 2 to power 2 by 3 and 2 to power 2 by 3 in numerator and denominator. Now numerator will be 2 to power 2 by 3 as it is and in denominator we will add the power. So 2 to power 1 plus 2 by 3, it will be equal to 2 to power 2 by 3 divided by 2 to power 3 by 3 which is 1. So we got 2 to power 2 by 3 divided by 2. Okay, so that's the way we can solve these types of question. So that's all for this video. In this video, we have done some operations on real number and after that we will define some properties and later on we have done the rationalization. So that's all for this video. Keep practicing. If you have any doubt, then you can ask me through my Urban Pro profile.